All right, folks, I'm excited about this unit. Things are going to get more interesting. Java is designed around something called object-oriented programming. Ultimately, the idea is that you can write blocks of code, think of them as different objects. They can even be written by different people, and you can pull them all together and make great creations, even though the pieces are kind of separate. That's a really loosey-goosey way of describing it. But the idea is, if you specify things right, you can have one person, bless you, you can have one person take care of one part of the code, and then you could take care of another part, and your code can work together even if you've never seen their code, because you've made an agreement on what they're going to handle, and it's sort of encapsulating their part in what we're calling an object, and the same with your stuff. So it's very powerful. It's a little more complicated than the alternative would be a procedural programming system where you just have like one file and you have code that starts at the top and just works its way down, which is how programming was when I learned how to program. So here's the deal. An object represents I'm going to say an entity from the real world. For example, a student, a book, a rectangle, a menu item, a menu in an app. So an object is going to be a thing. And we create objects. The template for objects are what we call classes. A class is a template or recipe or blueprint for an object. So you've noticed perhaps how when we compile our programs, like you have a program called day 7 and you compile it, and then there's another file that appears called day7.class. That's what we've been writing is classes. You just didn't know. And so I'll show you some specifics soon. But think of a class as whether you want to say a template, a recipe, or a blueprint. In a way, if we were making cookies and you rolled out a bunch of cookie dough, the class would be the cutter, the cookie cutter. And you can cut out as many cookies as you want using that class. Each one of those cookies that got cut out would be the objects. You can make as many objects as you want using a single class. So a class defines the attributes and behavior of objects. So let's get specific. Attributes are, you could say, or properties, are stored in variables, also called data fields. We're going to call them variables, but I didn't want you to freak out if you saw the word data fields. So for example, a rectangle object would have fields for width and height. So when you have objects in Java, they tend to have attributes. So, if you have a rectangle object, the only attributes you need are, well, for the most basic, rectangle would be how wide it is, how tall it is. I'm just giving you an example for that. Behavior of an object is defined by the class methods. So we had this thing called, you may have seen JGrass complain to you that there was no main method or something. That public static void main string args line, that's a method. We're going to see other methods starting today, and we'll start working with them a lot in Unit 2. And a method is like a block of code that does something. So a class can have as many methods as you want to have in it, and the methods do things. So you might have a rectangle object, like we're going to have shortly, that can tell you its area and its perimeter if you ask it, right? So the rectangle has, you might think of area and perimeter as being more attributes, but I'm thinking of those things that can be derived from width and height. So if we just go to the most basic things of a rectangle, you need to know the width and the height. And then in the rectangle object I defined, it has a method for getting the area and another method for getting the perimeter. Guess I can say that. Example, a rectangle can give you its area and perimeter. And I'm saying at least the rectangle that I've defined can do that. So we use the new keyword when we create an object. This is all going to get less mysterious in just a minute. So we only use this word new in Java when we're creating an object. And the act of creating an object is called instantiating an object. An object can also be called an instance of a class. Instance. These are just terminologies. So let's talk about if you had an apple pie recipe. It's like in a cookbook. And you make an apple pie. That's instantiating an apple pie object. And that apple pie that's sitting on your counter smelling so good, that's an instance of the apple pie recipe. So the object is the apple pie in the real world. The class is the recipe in the recipe book. So let's say we had, I'm going to show you right here an example of using that new keyword. If we were going to make a rectangle object, and I'm just going to show you one line of code here. You say rectangle R1, I'm naming it R1, equals new rectangle. And then I'm going to say this one is 3 by 5. So this is an example creating a rectangle object. Now, it assumes that there's a class somebody already wrote called rectangle. You can't just say, oh, make up a name and call it. That something has to already exist. But just to walk you through this, this is the class name, rectangle, and this is the name I'm giving it. It could be, hey, how you doing? Although you're not allowed to have spaces in a variable name. And then equals, and then that new keyword, and then the class name again, and then the way I defined my rectangle is it first is accepts the width, and then secondly accepts the height. So, but you could, if you were writing your own rectangle thing, you could have it do it differently. So from here, I want to show you. I've got this code here, and I'm going to give it to you when we're done. So don't try to copy down the whole program. I'm just going to email it to you. Public class day 7, and we got our standard main method, public static void main string args. And here's rectangle 1, R1 equals new rectangle, and see new changes color because JGrasp can tell it's a keyword. And then I made a rectangle that's 20 wide and 40 tall. And then I have 2 print calls where I say in quotes, R1 area equals, R1 area, and then this is, I'm calling a method. I'll show you that code in just a second. And then R1 perimeter, I'm calling code in the rectangle object that gives me the area and that gives me the perimeter. So I've already run it. It's right down here. But I guess to prove that it really is running and that it's not just a fake, I just compiled and ran again. And so the area of a 20 by 40 rectangle is 800. And the perimeter would be 20 plus 40 plus 20 plus 40, or 120. So hey, this works. Let's take a look at what this class looks like. There's more in it that's not showing. I can't show it all in one window. But let's take a look. We have public class rectangle. So this looks just like your public class day 7 and that stuff. But I have two variables defined here. These are the again, I'm going to send you this so you don't have to write it all down. Those are the data fields, the variables that are going to belong to each rectangle. And then this is called a constructor. That's the code that gets called when you create a new rectangle. It always has the same name as the class. See, this says rectangle, and this says rectangle. And I told you, for my rectangle, when you create one, you have to send it the width and the height. And that's indeed what happens here. Int w for width, int h for height. And we'll go over what's going on in here another time. I'm not making you write classes right now. And then here's a method that returns the area, get area. It returns the width times the height. And here's a method that returns the perimeter. And I did width times 2 plus height times 2. I mean, you could have said width plus height plus height. I was just trying to type a little bit less. So that's a whole class. That's our rectangle class. And you're not limited to just one rectangle, right? You can make as many as you want now. Like I'll make another one, and sometimes it's fun to make them with funny names. So rectangle haze equals new rectangle 55, 55. So I'm a square, and then my age is 55. Boom. Who just got owned? Anyway, that'll run fine. I think nothing will happen. I'm not printing it, but I did Control R, and so it compiles fine. You can make, as many, you can make a lot of rectangles before it would run out of room. They don't take up a lot of room. So I made a little diagram. Let me see if I can remember where it is. I think it's right here. Did I put it down below? No. I'm sorry, I'm just going to look for it. No, I guess I don't have it.